Hello, my darlings. Okay, so today we're going to talk about something called determinants. Every square matrix, which means the number of the rows is the same as the number of columns, has a related value called its determinant. Now, the determinant of a matrix is denoted by the three letters DET with parentheses around the matrix, or these straight up and down lines. They kind of look like the absolute value, so they're not square brackets. They change the square brackets to the absolute values symbol type thing, okay? That would mean find the value of the determinant. Now, how do we find that? So the determinant, it's a numerical value, and in order to find that, we're going to look at a 2 by, because the rules are different depending on the size of the matrix. So we're going to start with a 2 by 2 matrix. It is the difference, which remember means we subtract, of the products, which remember means we multiply, of the diagonals, but it has to be done in a certain way and in a certain order. So for instance, when we have this 2 by 2 determinant, we start at the upper left corner and we use the diagonal A times D. Then we subtract. Now we're going to start at the upper right corner, B times C for that diagonal. Now a couple things. The order is important. Okay, this product AD must be first. So you must start at the upper left product first. So let's write that. It's the upper left product, left diagonal product, minus the upper right diagonal product. Now it sounds complicated, but it's really not. You just have to remember which order you have to multiply. Let's try one. So I brought the rule over here, so it's still there. Remember, we're going to do this diagonal A times D minus this diagonal B times C. So if we have, now notice these straight up and down, they are not the square brackets, -5, 7, 3, 9. This is a matrix, which is an array of numbers. This is a determinant, which is equal to a numerical value. All right, so from the upper left, that diagonal would be -5 times 9, and -5 times 9, that's -45, minus, now we're going to use the other diagonal, 3 times 7. Now I'm writing out this step here so you can see what I'm doing. Do you have to write that out? No, not really, okay? So it's minus 3 times 7 is 21, and if we do that arithmetic, we are going to come up with -66, and that's the value of the determinant. Let's try another one. So again, we start at the upper left. We're going to do 5 times 1, which is just 5, minus, now we start at the upper right, -2 times 3, which is a -6, so plus 6, and 5 plus 6 is 11. And there we go. That's how we find the determinants for 2 by 2 matrix. Now, 3 by 3 matrix, that one's a little different. Notice the size. This example that I have down there is a 3 by 3 matrix inside those absolute value-like symbols, which means it's the determinant of the matrix. So the steps. First, we copy the first and second column in order to form a fourth and fifth column. So we're going to copy 0, 3, 4, and then we're going to copy 3, -1, 0. Okay, so far so good. Now what we're going to do is the determinant is found by adding the product of the 3 downward diagonals. So in other words, I'm going to open up parentheses here too. 0 times -1 times 1, which, by the way, is just 0, right? Plus, now I'm going to go to the next one. 3 times 2 times 4. 3 times 2 is 6, times 4 is 24. And then we got another diagonal, 1 times 3 times 0, so plus 1 times 3 times 0, which has a product of 0. Now, if you try to do another downward diagonal, there's only a 0 and a -1. There's no third number here, which means you're done in that direction, okay? So I'm going to close those parentheses. Then we're going to subtract. We subtract the sum of the products of the 3 upward diagonals. So we start at the left again. 4, -1 times 1. That's just -4. Plus, we do the next one, 0 times 2 times 0. And again, I'm writing out this first step just so you know where it's coming from. You can definitely go right to the second step down here. Plus, okay, 0 times 2 times 0 was just 0. We've got another upward diagonal, 1 times 3 times 3, which is 9. And if you try to do another upward diagonal, you have 4 times -1, but don't have a third number, so you know you're done. We can close that parentheses, and now we just have some arithmetic to do. All right, 0 plus 24 plus 0 is 24, minus -4 plus 0 plus 9 is 5. So 24 minus 5 is 19. And that is the numerical value of our determinant. Let's try one more 3 by 3, just so we make sure we've got it. Okay, so here's our 3 by 3 determinant this time. We're going to copy the first 2 columns. 3, 2, 1. Then -2, -1, 2. Okay. Open parentheses. We're going to do the downward diagonals. 3 times -1 is -3. So -3 times a -3, that's a +9. The next diagonal, -2 times 0 times 1, that's 0. -1 times 2 times 2. 2 times 2 is 4, times -1 is a -4, minus, now we're going to do the upwards. 1 times -1 times -1, that's going to be a +1. 2 times 0 times 3, that's 0. Plus -3 times 2 is -6. -6 times a -2 is a +12. Now we do a little bit of arithmetic here. 9 plus 0 minus 4 is 5, minus 1 plus 0 plus 12 is 13. And if we do 5 minus 13, we get -8. And that's the value of our determinant. All right, guys, so we have introduced the concept of a determinant, which we will be using in order to do some other things. And we learned how to find determinants for 2 by 2 matrices as well as 3 by 3 matrices. All right, that's it, guys. Have a great day. See you soon.